All right, guys, good morning. It is Wednesday and we're on lesson 84. I'm gonna work the first 15 problems, the odd numbers with you guys here in this first part of the video, and then in the second part, we'll do the rest of the problems. But for right now, make sure your book is open to page 406. We're on lesson 84. I'm gonna read through some of the information there. We're gonna look at a couple of things here on the board, and then we'll go to the problem. So follow along as I read. A percent may be quickly changed to a decimal number. Study the following changes from percent to fraction decimals. And here we see several examples that I've set up for you guys here. Notice that the decimal number has the same digit as the percent with the decimal point shifted 2 places to the left. So you see here 2 decimal places and 2 decimal places, but the decimal place has been shifted 2 places to the left, okay? So the way you can see this is we see a number like 15%, or a whole number 15 has a decimal at its end at the far right, okay? When we change that number to a decimal, okay, we're gonna divide it by 100, okay? Just like here, this could also be seen as 5 divided by 100. And the decimal point is gonna move, in this case, 2 places to the left to become 0.15, okay? And then we have another problem, example number 2. We have write 115% as a decimal. So think of 115 as a whole number. We're gonna drop the percentage, okay? We've got a whole number with a decimal point, okay? You could also write this number like this, okay? To hold place values here. But there's a decimal point right here. And when you're changing this percentage into a decimal, you are dividing it by 100. So that means the decimal point is gonna move 2 places to the left. So 115% would become 1.15. And then our final one is changing 1% into a decimal. Okay, same thing here. Decimal at the far right to represent a whole number. Okay. If you divide 1 by 100, your final answer would be 0.01. All right, so very short, very basic lesson. We're gonna practice some of these in the problems ahead. Some of them will be odd, but you'll have to solve a couple of them on your own for the even numbers, all right? Oh, 1 second. Okay, good. All right, so our first problem number 1. 21 of the 25 answers on Scott's test were correct. What percent of the answers were correct? So I've gone ahead and written it down. 21 of the answers were incorrect. I'm sorry, were correct or incorrect? Correct. So you got 21 answers right, but there was a total of 25, okay? We're changing this 21 over 25 into a percentage, okay? So I've set up my, my next fraction, okay, to represent a percentage. Remember, a percent is a fraction with a denominator of 100, okay? So I've got 21 over 25. 25 times what equals 100? So we think of quarters. If you have 4 quarters, you got $1, you got $1. So 25 times 4 is 100. Whatever we did to the decimal, we're gonna do to the numerator. So 21 times 4 would be 84. So my percentage is 84%. Okay, that's your final answer to number 1. Number 3, the cost to place a telephone call to Tokyo was $1.50 for the first minute plus $1 for each additional minute. What was the cost of a 5-minute phone call, okay? So I've represented my first minute as $1.50. So every other minute is gonna cost $1. So in this case, we're dealing with 5 minutes. So I've got $1 times 4. Remember, when we're doing an expression like this, we do the multiplication first. So I did $1 times 4 is $4. And then we simply added that to the first minute of $1.50 to get the final answer of $5.50. It would cost $5.50 to make a 5-minute phone call. Imagine if they stayed on the phone for like 2 hours. That would be a very expensive phone call. All right, next, number 5. Write 125% as a decimal number. Like we were seeing earlier here in the lesson, we have our whole number, 125, and I've represented it as a whole number with a decimal, and I'll even put a little 0 here, okay? So we can imagine 125 over 100, okay? So if we were to divide that, that means the decimal point is going to move 2 places to the left. Remember, when we multiply by 10 or by 100 or so on, the decimal point moves to the right. But because we're dividing, the decimal point is going to move to the left. So 125% expressed as a decimal would be 1.25. So your final answer is 1.25. Next, number 7. Write 60% as a reduced fraction. 60%, remember a percent is a fraction with a denominator of 100%. My numerator is 60, my denominator is 100. First thing I do, I'm going to cross these out to give me a smaller fraction to work with. So now I've got 6 over 10, but I can still reduce that because 2 goes evenly into both of them. And 2 goes evenly into 6 3 times, and 2 goes evenly into 10 5 times evenly. Okay, so your final answer is 3/5. All right, that is number 7. Let's go on to number 9. We're changing, write 13 over 20 as a decimal number, okay? So I've already set it up as a fraction, but we've got as a division problem. We've got 13 over 20, but we need to change it into a decimal number. My denominator becomes my divisor. My numerator becomes my dividend. I go ahead and drew my box in. 20 does not go into 1 or 13, so I wrote a 0. I lined up my decimal points, and I added a 0. Now I see, does 20 go into 130? It does, 6 times. So 6 times 0 is 0. 6 times 2 is 12. So now I have 130 minus 12. I subtract that. 0, 3 minus 2 is 1, and I bring down my 0. Now I try to see, does 20 go into 100 evenly? And it does. 5 times 0 is 0, and 5 times 2 is 10. Now I subtract that, and I don't have a remainder, and I found my final answer. So 13 over 20 expressed as the decimal would be 0.65. And then on to number 11. Go ahead and turn the page here. All right, we've got 2 1/2 plus x equals 3 1/4. So we have a missing part of our problem here that we're trying to find. It's the second part of an addition problem. So in order to find the second part of an addition problem, we have the sum. So we're going to take the sum and subtract the known part from it. So we have 3 1/4 minus 2 1/2. And now, remember, when adding and subtracting fractions, we need to make sure that they have a common denominator. To find the common denominator, we find the least common multiple of the denominators. In this case, we got 4 and 2. The least common multiple of 4 and 2 is 4. So 4 is the least common multiple. So I've got to change my 1/2 into a fraction with 4. In order to do that, I need to multiply my fraction by 2 over 2. Okay, so 2 times 2 is 4, 1 times 2 is 2. And we've gone over this in every video and every lesson that we've done over the last 3 weeks. We've had a problem like this, so I hope you guys have got it down by now. We've got 2 2/4 now. 1/4 already has a common denominator of 4, so we just multiply it by 1 or just transfer it over. We've got 3 1/4. Now we can go ahead and subtract. When subtracting and adding, we're only looking at the numerators. Now that they have a common denominator, we're only focusing on the numerators. So because it's a subtraction problem, I can't take away 2 from 1, so I need to borrow from the 3, make it a 2. Now, I'm borrowing a whole in fraction form. What does that mean? That means I'm borrowing 4 over 4. Now 4 over 4 equals 1, and that's the one I got from the 3. But I need to represent it as a whole fraction in order to add it to this fraction. Remember, they have to have common denominators. So I can go ahead and add those. So now I've got 5 over 4 minus 2/4, which gives me 3/4. And 2 minus 2 is 0. So my final answer is 3/4. That looks weird. There, that's a little better. 3/4. All right, on to number 13. We've got 3/4 times 2 and 2/3 times 1/2. Okay, so three different fractions and an improper fraction in there. I'm sorry, a mixed number in there. We've got 3 and 3/4, 2 and 2/3, and times 1/2. Our improper fraction needs to, our mixed number needs to be changed into an improper fraction, so I went ahead and did that. We've got 3/4 times 8/3. The way we got an improper fraction, the way we turn a mixed number into an improper fraction is we multiply the denominator by the whole number, so 3 times 2 is 6, plus the numerator is 8. So now I've got 8/3. And then I've got my 1/2 can remain the same. So I went ahead and multiplied these numbers, but remember we can cancel these out. So we can divide these. So 3 goes into 3 one time evenly. 4 goes into 8 2 times evenly. So now I've got 1 times 2, which would equal 2. And 1 times 2 times 1, which would equal 2. You see how both of these, 24/24 and 2/2, equal 1? That is your final answer, 1. All right, and we've come to our last one, number 15. We've got 6.5 minus 4 minus 0.32. The first thing we need to do is the operation within parentheses. So we take 4 minus 0.32. When subtracting decimals, we need to make sure that the decimals are lined up and all the decimal places are lined up. So I placed a decimal here to my whole number 4, and I added 2 decimal places in the tens place and 1 in the hundreds place. My decimal points are lined up. There's a 0 in the ones place here. Okay, so now I can go ahead and subtract. I've borrowed from the I borrowed from the 4 to make a 3, and that becomes a 10. I cancel that out, that becomes a 9. So now I've got 10 minus 2 is 8, 9 minus 3 is 6, and 3 minus 0 is 3. So a 4 minus 0.32 is 3.68. So now I can subtract 6.5 minus 3.68. So the larger number I put on top, 6.50, I added a decimal place in the hundreds place to hold its place value there. And I've lined up my decimals. So my 3 is in the ones place, my 6 is in the tens place, and my 8 is in the hundreds place. So now I can go ahead and subtract. Can't take away 8 from 0 or 6 from 5, so we borrow from the 6. The 6 becomes a 5, turning that into a 15. That becomes a 14, and now we can subtract 10 minus 8 is 2, 14 minus 6 is 8, and 5 minus 3 is 2. To give us the final answer for number 15 of 2.82. All right, make sure you do all the even number work. We're doing it all today on Wednesday. We're about to go over to part 2 and do the odd numbers for 16 through 30. All right, guys.